Hi everyone, welcome to Doc Hill's Study, where I help you get ready for your National 5 biology assessments. In this video we'll be walking through questions from an official SQA paper. The paper and the marking guide are both produced by the Scottish Qualifications Authority, the SQA, and all rights to that material belong to them. I'm using these resources strictly for educational purposes here on this non-commercial channel to support students like you in preparing for your exams. I'll be using the SQA's marking guide to highlight what answers are accepted, but keep in mind it usually only shows some of the correct answers and doesn't explain the reasoning behind them. That's where I come in. For each question, I'll walk you through the thinking process, explain what the question is really asking, and point out some of the common pitfalls to avoid. If anything doesn't make sense to you, or you want to ask about a specific point, feel free to leave a comment. I'll do my best to help you out. If you find this helpful, please give the video a like and subscribe to the channel so you don't miss any future walkthroughs. Let's get started. Question 5. All right, let's have a look at this question. The concentration of lactate in the blood of a long-distance cyclist was measured while cycling at different speeds. The graph shows these measurements at the start and end of the competition season. All right. Now, let's have a look. Question A. We're simply being asked to read the graph, I think. Let's have a quick look at the graph. Start of the season is the solid line, end of the season is the dashed line. They've plotted it, and we have a line, and they have a 0 point, or at least at 24 kilometers per hour. Now, we might have to watch out for this. This scale starts at 24. We're often used to seeing a scale start at 0. Okay, lactate concentration in units, so they've just given us units for a unit there, kilometers per hour speed. All right, let's have a look. What was the lactate concentration at the start of the season when the cyclist was traveling at 40 kilometers per hour? All right, so we've got 40 kilometers per hour, start of season. So we need the start of season line, which is the solid line. And we're looking at 40 kilometers per hour. So we just get our ruler out, or our pencil, 40 kilometers per hour. We're going up to this one, and we have to read the graph. Now let's just be careful. Every single tiny square in this is worth 0.2. So that's 1, that's 2. So 1 divided by 5 is 0.2. So every small square is 0.2. So we've got 2.2, 2.4, 2.6. The answer is going to be 2.6 units. All right, question B. Okay, calculate the percentage decrease. Here we go again, a percentage decrease, and we're going to have this going the other way this time, in lactate concentration at the end of the season compared to the start of the season when the cyclist was traveling at 52 kilometers per hour. Okay, let's see what we've got here. Calculate the percentage decrease. We're looking for a decrease. Lactate concentration at the end of the season, end compared to start at 52 kilometers per hour. Okay, let's get these numbers. End, start. This time we don't have to do any rearranging. We're just going to do the formula out. And we need to make sure we get the numbers for 52 kilometers per hour. So again, we're going to have to get the units at the end and at the start of season, end of season units at 52 were nice and easy 4. End was 4. End dashed line, yep. Check it. Start of the season was up here 6.2, 6.4, 6.4. Okay, good. Start of the season, 6.4. End of the season. Okay, so in this time we're going to measure the decrease. So the decrease is going to be a positive number. It's the other way around. We're going to have to do this one. So start minus end over start equals percentage change. In this case, it's the decrease. Okay, so decrease will be start minus n, and increase will be n minus start. Okay, so it's kind of tricky, and you have to remember this little formula. Oh, we have times 100 in there to give us a percentage. All right, so what have we got? Then we're just going to take start, which is 6.4 minus 4 over start, 6.4, which is going to equal 2.4 divided by 6.4. This is much easier for 1 mark than the previous one. And we're going to multiply that by 100. Sorry, get the 100 in there. Times 100 equals, okay, so on 2.4 divided by 6.4 equals 0.375 times 100 equals 37.5, and the answer is 37.5%. Okay. So far so good. Let's look at question C. So there you go. That's the second time that percentage change has come up, and we have to do it slightly differently this time. So you've got to be thinking all the time. And I tell you, this is much harder for biology students than it is for the physics and the chemistry students, because they get most of their relationships in a data booklet that comes with the exam papers. You have to remember these formulae. So good luck. You've got to sit down, learn them. That's the bottom line. All right, so question 5 continues. Calculate how many times greater the maximum lactate concentration was at the start of the season compared to the end of the season. Okay, so what do we need? We need maximum at start and end. Okay, so max start, max end. Let's write down what we need. So let's see. Maximum, well, here's the maximum at the start, right? And that's going to be 9. So the maximum at the start was 9.0. Just make sure that we've picked the right line. Start as the solid line. Good. Maximum at the end was 5.0. 5.0. Okay. How do we calculate how many times greater? Well, we just divide 9 by 5. So 9.0 divided by 5.0 equals, let's get it out, on 1.8. Okay. If you're worried about how many times greater, think about it the other way around. How many times do you multiply this number to get that? And it should be 5. Okay. How many times greater? So it's 1.5 times greater. Or what do we multiply this number by to get that? So there's various different ways of thinking about this. You've got to, but the way we divide it, so we times it, we're going to divide. It's the opposite. All right. So 1.8. Sorry about that rather vague description, but that's how we do it. And that's the end of question number 5. How did you do in that question? Again, this one here, tricky. And again, it could be easy to end up with a negative 37.5 here. And I don't think they're going to accept that in the exam. They've only got a positive value in the marking guide. So you've got to make sure you've got this the right way around. If you've got end before start, you're going to end up with a negative. And that makes it a negative increase rather than a positive decrease. So you've got to make sure that the answer makes sense, okay, compared to the question. These are tricky questions. And again, that maths, we have to remember it. Thanks for watching this walkthrough from Doc Hill Study. I hope it helped you feel more confident about tackling these kinds of questions. Remember, the answers I've used are based on the SQA marking guide, but it's always important to understand the reasoning behind them, not just memorize the words. That's why I focus on the process, not just the final answer. If you've got any questions, or if something didn't quite click, drop a comment below and I'll get back to you. If you found this helpful, give it a like, and don't forget to subscribe so you'll be notified when the next walkthrough goes up. Good luck with your revision, and I'll see you in the next one.